Hello everyone. Today I want to share my homework 6 homework file exercise 2.50. My homework is write a C++ program to control an LCD using a keyboard. Let's start our introduction step by step. First, let's look at the equipment we need. We have 4 main things. An Arduino Uno board. It's like the brain of our project. A 4 multiply 4 keyboard. We use it to press keys and input information. An LCD L1602 display. It will show the key we press. Several dopant wires. They help connect all the parts together. On the screen, you can see picture of these tools. The LCD 1602 has pins like VCC, GND, SCL, and SDA. We all use these pins later to connect to the Arduino. Now let's talk about how to connect the LCD 1602 to the Arduino. Our code uses this line tells us the pin connections. The RS pin of the LCD connect to Arduino digital pin 2. The E pin of the LCD connects to Arduino digital pin 3. The D4 pin of the LCD connects to Arduino digital pin 4. The D5 pin of the LCD connects to Arduino digital pin 5. The D6 pin of the LCD connects to Arduino digital pin 6. The D7 pin of the LCD connects to Arduino digital pin 7. Also, the VSS pin of the LCD goes to ground, which is the negative part. The VDD pin goes to 5 volt, the positive part, and the VO pin connect to a potentiometer meter that is used to adjust the contrast of the LCD, but in our simulation, we simplified this part. Next, let's connect the Multirix keyboard to the Arduino. From the code, we have 2 pin arrays. Row pins 8, 9, 10, 11. These are the row pins of the keyboard. Keyboard row 0 connects to Arduino digital pin 8. Keyboard row 1 connects to Arduino digital pin 9. Keyboard row 2 connect to Arduino digital pin 10. Keyboard row 3 connect to Arduino digital pin 11. Copins 12, 30, A0, A1. These are the column pins of the keyboard. So keyboard column 0 connects to Arduino's digital pin 12. Keyboard column 1 connects to Arduino's digital pin 30. Keyboard column 2 connects to Arduino analog pin A0. Keyboard column 3 connect to Arduino's analog pin A1. With these connects, the keyboard can set signals to the Arduino. Now let's look at the code structure, starting with the handler, fill, and initialization. First, we need to include the LCD library with include. This library helps us control the LCD easily. Then we internalize the LCD with Liquip LCD 2, 3, 4, 5, 6, 7. As we talked about before, the numbers here are the pin mappings for RS, A, D4, D5, D6, and D7. Next, we define the keyboard pins. We have two arrows, row pins for the row pins and color pins for the column pins. This arrow match the connections we did earlier. We also have a keyboard arrow. It's a chapter map. Each position in this arrow corresponds to the key on the 4 multiply 4 keyboard. For example, if we press a key in row 0 and column 0, the codon will use the chapter in keyboard. The next part is the setup function. This function runs only once when the Arduino starts. First, we interlight the LCD to 16 columns and 2 rows with LCD. The LCD 1602 has 16 chapters per row and 2 rows, so this line sets it up correctly. Then we print an interval message on the LCD we print. This message tells the user to press a key on the keyboard. After that, we set up the row pins. We use a loop to set each row pin as an output and set its level to high. Setting them to high is part of how we scan the keyboard later. Finally, we set up the column pins. Another loop set each column pin as an input with input pull-up. Input pull-up means we use the Arduino's internal pull-up resistor. This helps with detecting if a key is pressed. Now let's talk about the loop function. This function runs over and over again after the setup function. The core logic here is to get the price key first. We call the getPrice key function and store the result in a variable called key. Then we check if a key is priced. If key is 0, we move the cross to the second row of the LCD. The first number 0 is the column and 1 is the row. The second row size we start counting from the 0. After moving the cross, we print the price key on the LCD with LCD print. So if you press the 9 key, 9 will show up on the second row. At the end, we have a delay 100. This is a debounce delay. Sometimes when you press a key, the electronic signal can bounce for a short time, making the Arduino think the key was pressed multiple times. The 100 millisecond delay helps correct this mistake. Once we confirm a key is pressed, we first set the row level back to high, and then return the corresponding character from the keyboard error. The character is found using the character row and column index. If no key is pressed after checking all rows and columns, the function returns. Let's see how full system works. Let me see. This is summary. To sum up, our project realized the connection between Matrix keyboard scanning and LCD display. The core idea is simple. We pull down each row of the keyboard one by one, detect which column has a low level, and then use the liquid library to control the LCD and show the key chapter. The key teaching points we used are. This is my exercise. Thanks for your listening. Goodbye.